carbon fibre is the pinnacle of the bicycle world. A material that lets you build a frame as light as possible or as aero as you prefer. And most frames we'll ride are made in China and Taiwan, and that's cool, nothing wrong with that at all. But around the world there are a small handful of independent manufacturers offering another path, and one of them is Argonaut Cycles, based in Bend, Oregon, and this, their brand new stock frame, the Supernaut RM3. And isn't that a sensational looking bike? My goodness me. I see some stunning bikes on a fairly regular basis here at Just Ride Bikes, but this one, oh my days, what a bike. I love the proportions, the shape of the frame, very sort of classic but modern as well. And I love the fact we have the carbon fibre layout on show beneath the clear coat. They're not hiding the carbon fibre manufacturing process at all, it's there on display. In the same way that a steel frame, it lets you see how good the workmanship is by inspecting the wheels. We have the work on display here. So the new Supernaut RM3, there's also a gravel bike as well, but we're focusing on the road bike today, is their attempt to offer a stock frame for those who don't want or need a bespoke frame. Most of what Argonaut do is bespoke. 90% are bespoke frames. So every frame, the geometry, the carbon fibre layout, every proportion is measured just for you. It's still very much limited with just 30 bikes being made a year, and they're 13 sizes. So they're still taking your bike fit data, your power and your riding style and riding intention to tune and tailor the bike to your precise requirements. I've gone through the process with this bike and it fits me like a glove. A very, very good fit indeed. So today I want to give you a first look at the bike, point out some amazing details, and also have a conversation with Ben, Father, the founder of the company, and find out more about how the bike is made and how the new Supernaut came into being. And in a future episode, I'll give my thoughts on how the bike rides. I've had a quick spin on the bike in the last few weeks. I'll share my impressions at the end, but a bike like this deserves to be ridden a lot. So stay tuned in a few months' time for a full review. I don't want to rush this one. I want to enjoy my time on the bike for sure before it goes back and I move on to something else. And just for clarity, this video is not sponsored by Argonaut Cycles at all. I'm just passionate about sharing the most interesting bikes with you here on my channel, Just Ride Bikes.
The foundation of our company is really in custom carbon bikes. So custom in the terms of geometry, and then most, I think importantly, in a differentiating factor is the fact that they're custom in terms of layout pattern. So our focus in terms of delivering specific ride quality to a customer is to engineer the carbon inside the frame specific to their riding style, their weight, their power output, so that they get a bike that is really responsive to them as an individual. You know, I think that most high-end kind of race style road bikes are probably missing in terms of the ideal flex curve for most riders, and they end up coming across a little bit, dead and stiff unless you're just putting so much power into them. And I've, my history and my bias is more towards metal bikes, just in that they can deliver a really kind of more nuanced and more lively and more dynamic riding experience than I think a lot of production carbon can. So our main goal in our custom RM3 and our custom road bike was to deliver, a really specific tailored ride quality to the individual rider. So over the last, 5 years or so since we started making the RM3, it became apparent that we'd focused and come to use probably 5 different overall layout patterns for a lot of the different bikes that we were making. And I felt more and more confident that I could kind of make a great riding bike for more of like the average rider, I guess. specifically rather than sort of like starting from scratch every time. And then also, I felt like there were a handful of people who came to us who really wanted a great riding bike. They wanted to know the people who were making it. They were really into our engineering and technology story, but they didn't necessarily want to jump through all the hoops and really dive into a custom, like a whole custom bike project. Because for some people, that's really cool just to like pick their paint color and learn about the engineering of their specific frame and look at exactly how long they want their head tube to be and if they want an oversized pulley or not and just like there's so many facets of a custom bike. So some people love that nuance, and other people, I think riders are a little bit kind of like overwhelmed and worn down by it, and they just sort of want a great riding bike. And there wasn't really an option between us and something off the shelf. So we felt like we could offer, that customer of like somebody who comes in and just like, just build me your best bike, essentially. And that's essentially what the Supernaut is. If I just built the bike that I would build for myself, then that's the Supernaut. Like that's what we as the shop would ride and choose. So it's sort of like it's not it's not really an attempt to make a production bike. It's more just to give customers access to sort of like the chef's choice version of our bike, if you call it. The purpose of the Supernaut also is a way and a landing place for all of our engineering story. So our composite engineering, how we lay up our frame parts, high pressure silicone molding, all that stuff really gets lost in the custom bike conversation. A lot of times people come in and they're sort of like, that's all great, but can I get it the same color as my Porsche? Like, sweet. And the Supernaut, I think, it's kind of it's a specific individual consistent thing where we can talk about our layup pattern, our ply drops, our fiber geometry, our ride quality essentially that isn't specific to the customer, but it's just specific to the product. So it's almost like I wouldn't say it's like I don't know, it's something that we have that's ours that we kind of can be really proud of. Whereas a custom bike is like ultimately it's like the customers, right? Like we're sort of like we want to do whatever we can to make them happy, and so that's theirs. But the Supernaut is sort of like ours.
You mentioned something with your custom frames in terms of tuning the carbon layout, which I think is really interesting. You use power to optimize the layout. Can you expand a bit more on how you use all the data? Like,
Yeah.
well, because I've not heard anybody else using power. Normally it's about fits and biomechanics,
Yeah.
but using power, that's quite intriguing.
So if we look at the torsional flex of the frame, we want the customer to live kind of in the center line of the flex characteristic of the frame so that they're getting the most like snap and response out of the frame. Like if the frame is over stiff, you're never going to get into the ideal kind of spring part of the frame. Again, if it's too soft, then you're going to live sort of like in the bottom of your suspension stroke and you're kind of like going to bottom it out. And the bike's always going to be a little bit behind you, right? In terms of like the load and release as you put torsional flex into the down tube, into the pedal. So if a rider, there's the power output isn't necessarily linear to weight. So a really experienced, accomplished cyclist may weigh 165, what is that, like, 63 to 67 kilos in there and have an FTP of, 300 watts, say, and they can hold 500 watts for a minute, right? Like somebody who's like got pretty good power numbers, they're gonna live in a different part of that flex curve than somebody who weighs the same amount and just isn't putting as much power into the frame. So but at the same time, those two riders probably want a pretty similar amount of compliance. So in terms of how the bike soaks up road vibration, how smooth it is, essentially. And that's really the cool thing about doing layup and the layups that we have with unidirectional fiber is we can hold vertical stiffness, vertical bending pretty stagnant and turn up the torsional stiffness values without affecting bending. So those two riders, they're going to have different frames in terms of the torsional flex, but they're going to feel pretty similar in terms of like going across the road. So you can have a frame that is lively and snappy without it being harsh and chattery, essentially.
So how on earth do you tune the carbon layout then? Is that using computer software? Is that I imagine that's your top secret stuff. But can you shed any light on how you're able to do that as much as you're able to share?
Well, yeah, I mean, so I think the down tube is probably the most variable in terms of layout pattern through the bike because it holds the biggest, you can change the smallest amount of it with it changing the most in terms of the ride characteristics. Like, chainstays that we don't vary those a ton. Seat tube, we don't vary those a ton, but the down tube is like, it's like the femur of the bike, right? So it's really important for the ride quality. So it's just a good example. So we've developed, kind of 5 different key layup patterns for sort of like 5 different case studies across the rider spectrum. So we have, lighter, and they're all pretty relatively powerful, kind of like professional-ish sort of rider case studies, anywhere from like 115 pounds to like 130 pounds to like 140 pounds to 165 pounds, all through. And we've sort of identified these ideal layup patterns. And then when a customer comes in and falls between one of those, we'll kind of take that pattern and then we'll tweak the vertical stiffness, horizontal bending stiffness, and torsional stiffness specific to that rider. We'll sort of turn up and down the volume on that kind of case study, essentially. And the way that we do that is say that we want to, drive about a 12% increase in torsional stiffness without changing anything else. We'll probably take 2 of those interlaminate plies and change them from, say, like a 15-degree bias off of 0 to, we'll maybe cross those more towards like a 25 opposite, and changing those values that 10 degrees between those 2 plies could drive, these are estimate kind of calculations. I don't know exactly what they are. I have to actually go through and and use our spreadsheet and do the math, but that's just an example of that will drive about 10 to 12% of torsional stiffness without really changing the bending stiffness.
Okay.
And then alternatively, say we have somebody who we kind of know what their torsional stiffness should be from their power output, but they weigh another, call it 20 pounds or so. We can just take a couple of zeros and do like a couple of strips on the top and the bottom of the down tube. And that will drive vertical bending stiffness without changing the torsional stiffness values. So it's with those like kind of on a per ply basis and that individual ply geometry. That's how we can really specifically tune and tailor the bike. And that's why carbon fiber is such a great material for making bikes out of, is because it's so tunable. Like you can't do that with metal.
I guess that's why you make frames in where you are now in the USA. You couldn't outsource it to the Far East, could you? You couldn't have that control over the carbon plies and the layup.
No, and even, I mean, our most production carbon bikes, any given cross section has between like 5, maybe 7 layers, and it's a lot of weave. The thicker plies, it's just quicker to lay up, and you just don't have nearly as much control over the nuance of the ride quality, just because they're trying to make them faster. It's more material. It's not necessarily they're like, some of them there's all kinds of, some of them are really expertly made and perfect. Some of them are shit, as you know, but like they just across the board don't have nearly the complexity and layup pattern to really kind of achieve that really like holistic dynamic ride quality that we're going for.
Okay, let me give you a closer look at the bike, a bit of a tour around some of the details on it. And you have to see the bike on a sunny day like today to really appreciate the workmanship on this frame. It really does pop on a bright sunny day. You can see the full carbon glory around the dropouts, around the chainstays there. and around the top tube junction there. Look at that carbon weave on display. Absolutely stunning, really nice. So it's a nicely shaped frame. We have this sort of triangular down tube and a flat-sided top tube, oversized tapered head tube, and a nice fork that flows well into that head tube, down tube junction. And no drop rear stays, which I love, and almost not quite horizontal, but only a small slope to the top tube, and a wishbone rear stay assembly. I do like that sort of detail. Down to very chunky chain stays and square shaped seat stays, and a direct mount for the rear derailleur there. Lots of lovely details indeed. I do love the shape of that down tube indeed. See the carbon weave around that junction there. Get my shadow all over it though. So this build, pretty special. Top end of course, with the brand new NV one-piece cockpit. My first time on this. I like the taper from the middle to the tops there. With the out front mount slammed, of course, it really matches the frame nicely, and a matching NV seat post and a Repente saddle. Full Shimano Dura-Race Di2 with a ceramic speed oversized pulley wheel. Actually the first time I've used one of these, so interesting experience, and a matching ceramic speed bottom bracket. The company's own wheels. Now interestingly, they designed the wheels to be as stiff as they want to complement the compliance built into the frame. And I've not heard that sort of synergy between the wheel and frame stiffness before. I will swap the wheels for future testing, put some MVs in there and see how it handles different wheel stiffnesses. Look at the detail around the brake mount there, that is lovely. Full internal routing, of course. T47 bottom bracket down there. That bottom bracket junction is just lovely, really exceptional indeed. Just a lovely looking bike. External seat clamp, another nice detail there. So pretty special bike indeed. But how on earth did Ben come to manufacture such a high quality product? Well, let's find out from the man himself.
In making steel frames, I thought it was so cool that I could make, I made a bunch of like Columbus Max frames for really big riders, or some like, some True Jumper S3 frames for some racers, and just how different those bikes rode was like, that was the fun part for me. But then I quickly sort of ran out of options in terms of tube options, because there's only so many different steel tubes out there. So and also, I felt like my bikes in Portland, when I was working at the time, there were so many other steel builders and they were all really great builders, and we were using the same painter, and like my bikes are not any different than anybody else's. Like they just have a different name on them.
Yeah.
So that's what initially motivated me to get into making carbon. And I wanted to be able to take that same ability to tune ride quality I did with steel, but take full advantage of carbon as a material, to do that to such a higher degree, essentially. And so, but I was, I have a degree in history. I don't have an engineering degree. So at that point, I was a very competent steel builder, but I didn't have any experience with composites. So I was and I was really in kind of a little bit stuck, because the quality of frame parts that I needed, a small shop that would talk to a bike company, didn't have the ability to make. And then, a bigger shop, composite manufacturing facility that could make like high-end bladder molded frame parts and custom layout patterns didn't have any interest in talking to a small bike manufacturer, right? I mean, this is like Boeing and, their subsidiaries. So through happenstance, I luckily met a really great guy in front, he's still a good friend of mine, and about an hour away from Portland. The company is called Innovative Composite Engineering.
Okay.
So they're in White Salmon, Washington. So the last iteration of the Argonaut carbon bike, the RM2 call it, the space bike that we released in like 2011, we worked with them to actually mold all of our frame parts. So I worked with them to figure out the layout patterns, to design the frame and the tooling for them to make the actual composite parts. And then we built the frames with parts that they manufacture for us here in our shop. So they, and that was a really great relationship, and I learned a ton from them. This is kind of where I learned, this is kind of trial by fire where I learned so much about layout pattern and how to vary ride characteristics across, through layout pattern. They evolved more into aerospace and like space travel. So they now make a lot of stuff for rocket ships. Like they make the seat for the SpaceX rocket, make all this really cool stuff.
Wow.
So therefore, when I went to make the new frame, the new iteration of it, their machine shop rates went up quite a bit. So, I got a quote to make the next set of tooling, and I was like, well, for that, I can just buy a CNC machine and hire and, bring on a machinist and so that was really like the catalyst to bring everything in house. There wasn't any other facility in the US that could make the quality that they could make, and they couldn't do it anymore. And I learned enough from them to sort of do a next iteration and progression on the style of manufacturing that I thought was more specific to bikes.
So you're clearly determined to, despite the sort of lack of anywhere to have frames made for you or that expertise, I buy a machine, I buy a tooling expert, and self. You weren't put off. You were like determined even more to kind of let's do it myself.
Yeah, and I think it was important. One of the things that was important to me from the start was to make a carbon fiber bicycle that held up to like the highest standard in the industry, call it. So like the steel bikes that I was making were better, that I knew for a fact that they were better than like a steel bike made in an Asian factory, just in terms of the quality of the welding and the material selection and everything. That's not necessarily the case when it comes to composites, right? Like if I were to like buy tubes, back in the day from Edge, which is now Envy, and then, miter them and bond them together and do a reinforcement wrap, I couldn't stand there and say that bike was better than the latest, Specialized or Colnago, because a lot of the composite technology in Asia, in terms of the bike industry, in a lot of ways is really ahead of more bespoke builders across the world. So it was really important to me that from a composite engineering standpoint, the bikes really held up to really, really high scrutiny. So, that's that quality, essentially, that being able to maintain your fiber orientation, the compression, the interlaminate compression, your void content, all those things that make great composite parts. If I was going to do it, if we're going to do it in-house, like that quality is the point. Otherwise, what's the point? I mean, it's way easier to go and have somebody else in Asia make 1,000 frames for you. All you need to do is design them. Yeah. So the only reason to do it here is to make it better.
Now let's talk about price and build, and of course a bike like this comes with a big price tag. Not going to be cheap, is it? So the bike comes in a choice of high-end builds, SRAM Red or Shimano Duro DIT, which I have here, with appropriately high-end parts.
And it costs $16,500.
Which, yes, it's a lot of money. There are many cheaper bikes you can buy, of course, but I'm not going to stand here and justify this in terms of value for money, but there are some things worth bearing in mind before you go down to comments and see how outrageous that price is. Firstly, from Trek, the Madone SLR in top end build is $17,000, and a Pinarello Dogma F is anywhere from $16,000 to $20,000 depending on the build and finishing kit, and neither of those bikes are made in the USA or Italy, so worth bearing that in mind. But I'm not saying that bikes made in the US are better than those made in China and Taiwan, far from it. It's more that a company like Argonaut Cycles, just 18 employees, spearheaded by Ben Farther himself, have much more control over the manufacturing and every step of the frame's genesis, from an idea to a finished bike here. They can be more nimble and agile and responsive and change things as they want, because they're not investing in one mold, but they have to make as many frames from as possible to get the maximum return on investment from that mold, and molds are very expensive indeed. And it's also about the attention to detail. That relationship, that journey a customer has with the brand is very different to buying that Trek or Pinarello, which is much less personal than the relationship you have with a small, independent, passionate bike company like this. It's not saying that Trek and Pinarello are not passionate, because they are. I've met the people behind the brand, they are very passionate cyclists indeed. But they make lots of frames. Argonaut makes very few, and it's a very different relationship between the customer and the brand. But what matters most at the end of the day is how the bike rides. So let me share some first impressions ahead of a full in-depth review in the next few months. My first ride on the new bike came as something of a shock, I have to say. I just wasn't expecting this level of ride quality. It just floats along the road like riding on a cushion of air. So nice. Now, I've been lucky to ride many carbon bikes over the years, and they all impress in different ways, but many, especially race bikes, are just too stiff. Like the Pinarello Dogma F, for example. Amazing race bike, but too stiff. Like riding a metal gate along the road. There's no feel, there's no feedback from the road in a good, positive way. Just lifeless and soulless. And why I like riding metal bikes, steel, titanium, because they have this ride quality. It's kind of hard to put in words. It's sort of intangible mix of the geometry and the tubing and the components, but gives a nicer, more enjoyable ride quality. And I know ride quality is an interesting one. You can't measure it, you can't put a number on it. It's more subjective. But it's actually what I look for when testing bikes, more than aerodynamics and more than weight, because it's about the experience of riding the bike, how the bike feels and how it makes me feel, and the simple enjoyment of riding a bike. I've done 4 rides on this new bike so far, and every one I smiled the whole way around my loop. It does ride so nicely and makes me want to ride more, whatever the weather. So yeah, pretty impressive bike. Stay tuned for a full review in the next few weeks and months once I log some more miles on the bike. Anyway, that's all for today. Thank you so much for watching. I'll see you again very soon.